Good morning, students.
Good morning, ma'am.
Okay, very good morning. Are you ready for the revision? Today onwards, we are going to start our revision of first chapter, light reflection and refraction. Refraction. So today we are only discuss about the reflection of light. I have only asked you to study from page number 160 to 170. Are you ready?
Yes, ma'am.
Yeah. So first of all, we can make a simple picture of this chapter. After that, we can start these questions and all. One minute. Okay, enough. So this is about the chapter light. In the case of light, here we are discussing mainly two types of phenomenon. One is reflection and other is refraction. Today we are only going to check with the reflection of light. Reflection of light. So under this topic reflection, we study two laws of reflection. Did you remember the two laws of reflection?
Yes, ma'am.
Okay, so starting with a John Samuel. State the first law of reflection of light. First law of reflection.
The incident ray and the reflected ray and the normal is on the
Incident ray, reflected ray, and normal.
it's on the same plane.
All lies in the same plane. Okay, very good. Then the next question to Melvin. State the second law of reflection. Second law of reflection.
Yes, ma'am.
Second law of reflection. Second law of reflection of light.
The angle of incidence is always equal to the angle of reflection.
Yes, angle of incidence is equal to angle of reflection. That is, angle I is equal to angle R. Next question to Lolita. The next topic, types of mirror. What are the two different types of mirror that we discussed here in this chapter? Types of mirror.
Ma'am, is it free vision?
Yeah. After that, after the main picture of this chapter, we are going to discuss some MCQ samples. Two types of mirror.
Ma'am, real images and virtual images.
Types of mirror, not the images. Nirupama.
Ma'am, concave and
Concave and convex is actually comes under spherical mirror. We discuss one more type of mirror, that is plane mirror. Okay, so mainly the mirrors are classified into two. One is plane mirror and other is spherical mirror. So a next question is to refer. What are the characteristics of image formed out by the plane mirror?
It will be same size,
Okay, same size,
laterally inverted.
laterally inverted,
Real image.
real. Is it is real image, real and inverted image? Yeah.
Yes, ma'am.
Okay. What about is it is inverted? It is
Yes.
not real image. It is virtual image and erect image. Then
Then erect.
erect, virtual and erect. Then okay, it's enough. Then what do you mean by spherical mirror? Vishnu Priya, what do you mean by spherical mirror?
Spherical mirror is a mirror with its reflecting surface either curved inwards or outwards.
It is either curved inwards or curved outwards. Based on that, we are classify the spherical mirror into two. What are they? Concave mirror and convex mirror. Concave mirror and convex mirror. Then Adil, differentiate between concave mirror and convex mirror. Adil Muhammad, what do you mean by concave mirror?
Concave or converging mirror whose reflecting surface is curved inwards.
Which
Convex
mirror is it? Is convex or
diverging reflecting surface is curved
outwards. So in the case of concave, concave means as its
outward.
name implies it's cave-like structure whose reflecting surface is curved inwards. Such type of mirrors are called concave. And in the case of convex mirrors whose reflecting surface are bulged outwards. Here it is curved inwards, and in the case of convex it is bulged outwards, or it is curved outwards, are called a convex mirror. Then to both of these mirrors, concave and convex, they possess some kind of common parts like pole, center of curvature, focus, radius of curvature, and focal length. So first of all, we can differentiate each of these terms, and after that we can move to some problems. So starting with the Hadi. What do you mean by pole of the mirror? Pole. Pole of a spherical mirror. Pole of a spherical mirror. Aditya M.
Yes, ma'am.
What do you mean by pole of a spherical mirror?
Middle.
Yes, it is represented by P, and how we can define the pole?
The center. No, not the center of curvature. It's middle.
It is the center of what, or
Center
middle of what? Something.
Of the mirror.
Center of the mirror. Center of the mirror is actually center of curvature. No. Aman.
Center of reflecting surface of the spherical mirror.
Yes, it is the center of the reflecting surface of a spherical mirror. So suppose you imagine this is a concave mirror. The center of the reflecting surface, this is the reflecting surface of a concave mirror. So the center of the reflecting surface of a concave mirror is known as pole of the mirror. Actually, in most of the cases, students are make this common mistake. They are think that both the pole and center of curvature are same. Both are different. Center of curvature is the center of the spherical mirror, where the pole is represent the center of reflecting surface of the spherical mirror. So the next term, center of curvature. Here it is already discussed, or we are explained what you mean by center of curvature. As Aditya said, center of curvature is the center of the spherical mirror, where pole is the center of reflecting surface. The next term, focus. Hey, Steve, what do you mean by focus?
Focus the principal focus on you.
Yeah, focus. Simply the focus means principal focus, represented by capital F.
In a concave mirror, rays of light parallel to the principal axis. After reflection, it at principal focus. That is.
Okay. Then what do you mean by principal axis? Amina Naurin, what do you mean by principal axis?
Ma'am, principal axis, the line through the pole and the center of curvature.
Very good. If here we have a center of curvature, that is the center of the mirror, then the line that is passing through the center of curvature and the pole is known as principal axis. It is not a particular point, it is a line. So principal axis is a line that is passing through the center of curvature and the pole. So here we have pole, center of curvature, and the principal axis. Now we are going to define what you mean by principal focus. In the case of a concave mirror, the rays of light that is coming parallel to principal axis, after the reflection, what happens to this ray of light? It is passing through a particular point on the principal axis. This particular point is known as principal focus of a concave mirror. Students, can you guess what happens in the case of a convex mirror?
It goes outward.
Very good. The ray of light that is coming parallel to the principal axis, after the reflection, it is diverges away from that of a particular point That particular point is known as principal focus of, that is what is known as principal focus of a convex mirror. Okay. So the next term, radius of curvature. What do you mean by radius of curvature? Radius of curvature, Badra. Try to define what you mean by radius of curvature of a spherical mirror.
The radius of the sphere of which reflecting surface of a spherical mirror forms a part.
Yes, radius of curvature means it is the radius of the spherical mirror. We know that spherical mirror is a part of the sphere. It must possess a radius. So it is the radius of the sphere in which the spherical mirror is a part. This is what is known as radius of curvature. It is represented by the letter R. Then the next question, what do you mean by focal length? If and only if you know these terms, then only we can do the problems based on this chapter. That is why I am just quickly recall all the terms associated with the lesson. What do you mean?
Between pole and focus.
Yes, very good. It is the length between pole and principal focus. The length between pole and principal focus is known as focal length. How we are representing the focal length?
Small f.
It is represented by small f. Okay, very good. The principal focus is represented by capital F, where the focal length is represented by small letter f. So this part is over successfully. The next one is rules for image formation. How many rules are there for the image formation? That is, we are going to discuss the ray diagrams using spherical mirrors. How many rules are there?
4.
4 rules are there. So first rule.
A ray of light which is parallel to the principal focus.
Yeah.
Parallel to the principal focus.
After the reflection. Yes, it's right. The ray of light that is coming parallel to principal axis, not principal focus, or if the ray of light that is coming parallel to principal axis, after the reflection, it is passing through principal focus. The second law is exactly opposite to that of the first case. That is, the ray of light that is passing through principal focus, after the reflection, what happens?
Emerge parallel.
It is emerges parallel to that of the principal axis. So here we can make a quick revision of this rules for the image formation according to our first rule. Suppose we are considering, here we have pole, focus, and here center of curvature. According to the first rule, if the ray of light that is coming parallel to principal axis, this is our principal axis. So when a ray of light is coming parallel to principal axis, after the reflection, it is passing through principal focus. This is our first rule for the image formation. Okay, so if the ray of light is coming parallel to principal axis, after the reflection, it is passing through principal focus. Now, the second case. What about our second case, second rule? Here we have pole, focus, center of curvature. Try to recollect the second rule, just opposite.
A ray passing through the focus.
If the ray of light is passing through the principal focus, then what happens to?
Parallel to the principal axis.
Yes, after the reflection, it emerges parallel to that of the principal axis. So you just compare the first two rules of image formation. Okay. So in the first case, if the ray of light is coming parallel, here the ray of light is coming parallel. After the reflection, it is passing through principal focus. Passing through F. Okay. In the next case, the ray of light is coming. It is coming through F. If it is coming through F, the only way to return is it is going parallel to principal axis. This is our second rule of image formation. The third rule is the very simple. What about third rule?
A ray passing through the center of curvature after reflection is reflected back along the same path.
Yes, very good. If the ray of light is coming through center of curvature, after the reflection, it is returning through the same path. Very good ray of light. It is coming through the same path, returning through the same path itself. If the ray of light is coming through the center of curvature, it is returned through that of the center of curvature itself. So this is our fourth rule. Okay, sorry, third rule. Now we have one more rule. Here we have pole, focus, and center of curvature. So according to fourth rule, can you recollect the fourth rule for image formation?
A ray passing through the center of curvature goes back to the center of curvature.
That is the third rule. If the ray of light is coming through center of curvature, it is returning through the center of curvature. The fourth rule is, if a ray of light is, yes, it is incident obliquely. Obliquely means in a slanting way. If the ray of light is incident obliquely to the pole, after the reflection, it reflected obliquely from the pole itself. Okay, so this is what is our 4 rules of the image formation. Image formation using this mirrors, both concave and convex mirror. Next one is sign convention. Did you remember the sign convention?
Yes.
Based on this sign conventions, we are doing all the numericals. If the object is always kept on which side of the mirror?
Left side.
Yes, very good. Object, here we just consider a coordinate system. Here the mirror is placed with the pole at the center. According to first law of sign convention, the object is always placed on the left side of the mirror. And all the distance that is measured from pole towards the left side takes which type of values? Positive values or negative? It always takes negative values. All the distance that is measured from the center of pole towards the right is takes, girls?
Positive.
Positive values. Very good. All the distance that is measured above the pole or above the principal axis is takes positive value. Similarly, all the values that we are measured below the pole is taken, or the below the principal axis is taken negative values. This is what is about the conventions. Sign Cartesian convention rule. Then the last one, uses of mirrors. Can you recollect any 2 use of concave mirror? Concave. Concave mirror. Oh, yeah.
In torches.
Yeah, with the mirror that we are used in torchlight. Torchlight, headlight. Students, you just kept in mind, in almost all the lights, we are using this kind of concave mirror. Okay, torchlight, headlight, searchlight, or then can you say any other example?
Dentist use to see the larger image of the.
Very good. The dentist mirrors are all examples of the concave mirror. What about convex mirror? Convex.
Car mirror.
Rear view mirrors of car. Very good. Rear view mirrors of car. One more example.
Safety mirrors.
Safety mirrors. Convex there are 2 examples for convex. One is rear view mirrors of car and safety mirrors. Okay. Headlight of cars. Headlight of cars are example for concave or convex.
Convex.
Headlight is light. Concave. All the mirrors that is related to light comes under concave mirrors. So sometimes you maybe make some kind of mistake whenever you hear that headlight of cars. So you just write it is convex. But convex is the rear view mirrors of the vehicles. It only comes under the convex. All the other mirrors are concave in nature. The last one, mirror formula and magnification formula. What about the mirror formula? Mirror
1
formula.
by U plus 1 by V is equal to 1 by F.
Yes, 1 by F is equal to 1 by V plus 1 by U. First, we give the preference to image distance. Can you differentiate each term of this equation? F? F represents?
Focal length.
Focal length. F represents focal length. Okay, then V?
Image distance.
Image distance. When you write the equation, you must give preference to image distance. After that, write the object distance. Then U represents object distance. Okay. So this is what is known as mirror formula. And the mirror formula, you just kept in your mind, between image distance and object distance, here we take an addition sign, positive sign. 1 by V plus 1 by U. This is the another area you made some kind of mistake in connection with that of the lens formula. In the case of lens formula, here we have negative sign. In the case of mirror formula, here we have 1 by F is equal to 1 by V plus 1 by U. Most of them are made this kind of careless mistakes while you are writing the PT1 exam. So that is why again and again you are just kept this point in your mind. In the case of mirror, it is positive. Yes?
I mean, non-question answer, is it U or V always negative?
In every cases, U is always negative. U. Because the U is represents the object distance. U represents object distance. It is always placed on the left side of the mirror. So according to sign Cartesian convention, we must put a negative sign for U. So here we started to practice some numericals, then it will be more clear. Okay. The next is magnification formula. Mirror formula along with that magnification formula. What is our magnification formula?
M is equal to height of the image by height of the object.
Yes, M is equal to H dash by H. This is one equation. One more equation is there. M is equal to?
Negative V by U.
Very good. Negative V by U. In the case of mirror, magnification M is equal to negative V by U. In the case of lens, it becomes positive V by U. And depending upon the magnification, we can say whether the image is small, enlarged, or if it is in the same size. For example, if M is equal to 1, what about the size of the image? M is equal to, yes, it is same size. If M is less than 1, it indicates
Smaller one.
small size, smaller one. Okay. If M is greater than 1,
Bigger.
it is bigger or large. Similarly, depending upon the magnification value, whether it is positive or negative, we can say whether the image formed is virtual and erect or real and inverted. If M is positive, which indicates the image formed will be virtual or erect. Yes, the image will be virtual and erect. So students, you must keep this combination in your mind. Along with the erect, we have only one combination is possible, that is virtual. So if the M is positive, M positive, we have virtual and erect. Virtual and erect. Similarly, if M negative, we have only two combination is possible, real and inverted. Okay. So that's all about a picture of that part, reflection of light. Now we are going to solve some MCQ problems.
No.
Okay. So this is actually a problem based on case study method. Try to read the paragraph and find the answer. The following diagram is the solar furnace. It is used to generate heat using sun radiation. We know that we are studying one application of concave mirrors. Concave mirrors are used in solar furnaces. The solar furnace consists of a flat solar tracking helisostat, a parabolic collecting mirror, an attenuator or shutter, and the test zone area. Read the given paragraph carefully and find the answers for the following.
Ma'am, is it B?
Yes,
Is it B?
for first one.
Yes, ma'am.
What is solar furnace? The options are uses concentrated solar power to produce high temperatures for industry, uses solar energy to evaporate water and collect it within the same closed system, use solar energy to dry substances, use solar energy to dry liquids. Which one is the correct option?
A.
Here we have only D. 4 options are there. A, B, C, D.
A.
Which one? E. Here I can see the option E.
A. A.
Yeah. Option A is right. Because solar furnace is mainly used to concentrate the solar power. Solar power means the radiation that is coming from the sun. With the help of a concentrator, we concentrate all the radiations here and it is used to produce high temperatures for industry. It is not only used to dry the liquids or to dry the substances, or your solar energy is not only used to evaporate water. It is not used by evaporating water and collect within the same closed system. So the option number A is right. Good. Read the second question. Select the material that can be used as a helisostat surface to the reflex maximum radiation.
Ma'am, B.
Ma'am, C.
Read the question
B.
carefully and observe the figure. Here, this is the heliostat. Select the material that can be used as a heliostat surface to reflect maximum radiation. Ribbon silicon, polycrystalline silicon, and a convex mirror and a plane mirror. Which is the right answer?
Plane mirror.
Plane mirror.
Yeah, it's a plane mirror. You just observe, students, here the image. So we can use a plane mirror. Plane mirror is the right answer. Because polycrystalline silicon or ribbon silicon is not a reflecting area. We need a reflecting area. Then only we can reflect more amount of the radiation that is coming from the sun. So the correct answer is plane mirror. Plane mirror. Select the material that can be used as a heliostat surface to reflect the maximum. So here they are only giving an idea about the heliostat. You just observe the figure carefully. That is what is known as case study method. Study the given paragraph or the image very carefully. Then only you get the clue. Heliostat means something that is a planar area with a planar surface. So plane mirror. The next question. The device that can control the amount of light entering the furnace. Concentrator, heliostat, attenuator, none of the above.
Concentrator.
Ma'am, C.
Yeah, read it carefully. Observe the figure carefully. Then only you will get the answer. The device that can control the amount of light entering the furnace. Control the light. You just observe the figure. The radiation comes from here. It is false or plane surface. That is what we are call it as heliostat. So here we are using a plane mirror. Then the reflected rays from this plane mirror goes through what? It goes through which part of this diagram? Attenuator. So the correct option is attenuator. Because here this attenuator is allow the radiations in order to enter into concentrator. Okay, so here the correct option is C, attenuator.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Okay. Now we have the remaining questions. Name the parabolic mirror used in this process. Name the parabolic mirror that is used in this process.
C.
Yes, it is concave mirror. Name the parabolic mirror that is used in this process. Carefully observe the figure and find out the type of or the nature of the mirror that we are used here. Is it is concave or convex? This is the concentrator is known as the parabolic mirror. Which is the mirror that we are used here in this process? Is it is concave or convex in nature?
Concave.
Concave. Why? Because the reflecting surface is curved inwards. Here the reflection is possible. So the reflecting surface is curved inwards. So we can say it is a concave mirror. It is a concave mirror. So the option C is right. Okay, good. Then one more question. What are the types of solar furnaces? What are the types of solar furnaces? Indirect and concentrating solar power technology, active and direct, passive and heliostat, direct and heliostat. Any idea? Actually, this is a question that is coming from outside. The correct option is direct and heliostat. Direct and heliostat. Because we get the sun's radiations directly from that of the sun, not by any other kind of methods or active methods. So it is a direct method, and here we are using heliostat. So direct and heliostat method of solar furnaces are there. What are the types of solar furnaces? Direct and heliostat type of solar furnaces are there. So sometimes whenever the case study method, this is the what is the problem of regarding with the case study method, they give a paragraph. Sometimes the answers will not be there. You are carefully reading and through this paragraph, but you just think and answer. In case study questions, think and answer regarding, you just connect something that we are studying in our class. So solar furnace is something that we are related to that of the concave mirror. So anyway, you don't need to write anything or think about the convex mirror. Connect all the ideas and topics that is connecting with the concave mirror. Okay, can we move to the next question?
Yes, ma'am.
Okay, now there one MCQ sample question papers are there, but one problem along with that some answers are provided. Anyway, we can just discuss one by one. First question, an object is placed at a distance of 0.25 meter in front of a plane mirror. The distance between the object and the image will be 0.25 meter, 1 meter, 0.5 meter, 0.125 meter. Here the answer is given.
0.25 meter.
Yes, and why they give the explanation why? Here we are consider a plane mirror. Here we are considering a plane mirror. And what is the characteristics of a plane mirror, students? Characteristics of a plane mirror?
Distance will be same.
Yes, the distance will be the same. The distance between the image and that of the object will be the same. So here they provided the object distance 0.25. Then what will be the image distance? It also 0.25. So the object is placed at a distance of 0.25 meter in front of a plane mirror. The distance between the object and image will be given by 0.25. That is the object distance plus 0.25. This is the image distance. So in total we get 0.5 meter. This is the distance between object and that of the image. Object and image. The distance between both the object and image becomes 0.25 plus 0.25 is equal to 0.5 meter. Next question. The angle of incidence for a ray of light having zero reflection angle is 0 degree, 30 degree, 45 degree, 90 degree.
90.
0 degree. Angle of incidence is equal to angle of reflection.
Angle of incidence is equal to angle of reflection. So the answer is A. Angle of incidence of a ray of light having zero reflection. So incident angle is equal to 0. Then what will be the reflecting angle? Reflecting angle is also will be equal to 0. According to our second law of reflection, angle of incidence is equal to angle of reflection. Next question, third question. For a real object, which of the following can produce a real image? For a real
Concave mirror.
Concave mirror.
Plane mirror.
real image, we need the
Plane
real
mirror.
image.
Plane mirror.
Plane mirror.
Plain mirror produce a real
No,
image?
it is virtual
Map
angle.
concave mirror.
Which is the correct answer? Plain
Con-
mirror, concave mirror, concave
Concave mirror.
lens or convex mirror?
Concave mirror.
Concave mirror, fixed.
Ma'am,
Yes,
lens.
Ma'am.
What about concave lens? Today we are not, actually we are not asked to study the concave lens. Concave lens is a lens, it is always produce virtual and direct image. You must keep this point in your mind. So which mirror is always produce concave mirror? Concave mirror. Concave mirror is actually producing the real and inverted image. In the case of plane mirror, students, did you get the real image when you are standing in front of a plane mirror? It is a virtual, upright image you
No,
get,
virtual
right?
mirror.
Okay, in the case of a plane mirror, the image formed will be virtual. Along with that of the virtual, only combination is possible, virtual and direct. In the case of convex mirror also, only two cases are possible. It is virtual and direct. In the case of concave lens, only two cases are possible. It is also virtual and direct. So the right answer will be concave mirror. Concave mirror, the first table. The first table we get, I think 4 or 5 cases are real and inverted. So the real image is possible for concave mirror, real and inverted. Is it clear?
Yes, ma'am.
Okay. Okay, children, it's a time. We can discuss the same session for the next class also. You just study the same portion. Don't need to study about the refraction of light, only the reflection. Okay, reflection of light. That is from page number 160 to 170. The same portion. We can discuss more, we can discuss and practice more questions. And this is my humble request to you to, you must collect maximum possible questions from this portions from your part also. If you find any kind of doubts or regarding questions from this area, you can collect, we can discuss in the class. Okay. Case study method, assertion and reasoning method and all. Okay. Okay, children,